Hey everyone, it's Miss Mac here with another video. This time continuing with our work on functions. Today we'll be looking at how to find the domain and range of continuous functions. So our learning targets for today are first, that we can tell the difference between a continuous and a non-continuous function from a few examples, and also that we can find the domain and range of a continuous function. So first I want you to take a look at these two graphs and think to yourself, what is similar about these two graphs and what is different? Pause the video for a moment and think. All right, hopefully you had a chance to think about these two graphs, and maybe you noticed that they share a lot of the same points, that their axes are labeled the same, and that they both appear to be going in a straight linear direction. So a continuous function is a function that can be represented by an unbroken line or curve. So let's look at the graphs that we just looked at and think about which of these two functions is a continuous function. Hopefully you said graph B. Graph B is an unbroken line, and so it represents a continuous function. We would say that graph A is a discrete function or a non-continuous function. Here are some examples of continuous and non-continuous examples. Go ahead and pause the video for a moment and try to decide for yourself whether each of these examples is continuous or not continuous. All right, hopefully you've had a chance to think, and let's go through these examples together. So example number one is not continuous. This gives us essentially some ordered pairs, and we've just represented those ordered pairs as a mapping diagram. So this is not a continuous function. It would look like a graph, something kind of like example A from before. Example 2 is a continuous function because it is an unbroken line. Example 3 is not continuous because it is not an unbroken line or curve. Next, we have some word problems. The first word problem on the bottom says, a hose fills a 10,000-gallon swimming pool at a rate of 10 gallons per minute. This is a continuous function because the swimming pool will literally continuously be adding water. Each second, each millisecond, there will be more water added into the pool. So this isn't going to give us a bunch of ordered pairs. This would give us a continuous line if we were to put this situation on a graph. The next word problem says, a restaurant needs to order chairs for its tables. One table can accommodate 4 chairs. This is not a continuous function because this would give us a set of ordered pairs. If I had 1 table, that would be 4 chairs. If I had 2 tables, that would be 8 chairs. You can see how if we continued with this pattern, it would give us a set of ordered pairs. And finally, we have a bowler pays $2.75 per game. This is also a not continuous function, just like the example we just talked about, because this will give us a set of ordered pairs. So for example, in game number 1, a bowler would pay $2.75 for his first game. How much would he pay for a second game? Hopefully you said $5.50. So if we continue with this pattern, we would have a set of ordered pairs. And again, this would create a situation where we do not have a continuous function. Before we move on to find the domain and range of continuous functions, I wanted to revisit the definitions for domain and range. The domain of a function is all of the x values of that function, and sometimes we call that the inputs or the independent variable. The range, on the other hand, is all of the y values of a function, and sometimes we refer to that as outputs or the dependent variable. So we know that when we are looking for domain, we will pay attention to all of the x values or the x-axis, and when we are looking to range, we will pay attention to all of the y values or the y-axis. So here are some steps to find the domain of a continuous function. First, we're going to look for the value farthest to the left and record that number. Then we're going to look for the point farthest to the right and record that number. And finally, we will create an inequality with x in the middle, and we will use the two values that we found in our previous steps. So here's our first example. We know for domain, we need to be looking at just the x-axis because domain refers to all of our x values. So we will ignore the y-axis for now. Step number 1 says we are going to look for the value farthest to the left on the x-axis. So if we go all the way over to the left, you can see that we have a point to the left and it is located at -4 on the x-axis. So if we went to that point all the way on the left and we followed it down to the x-axis, we would get to the point -4 on the x-axis. Next, we need to look at the point farthest to the right. And the point farthest to the right on this graph is located at -1 on the x-axis. So when we go to that point all the way to the right, we follow it up to the x-axis and we notice that we are at the point -1. Our last step is that we will need to write an inequality with x in the middle. So when we are writing these inequalities, we generally always use a less than or equal to sign. And we put the number we found first all the way to the left, we put that on the left side of the inequality. We put the number that we found all the way to the right on our graph to the right of our inequality. So we have -4 on the left, -1 on the right. But I noticed something about the circles that I have on this graph. I noticed that I have 2 closed circles. And we've done a lot of work with inequality so far, and we know that when we have closed circles, that means there is a line underneath our inequality symbol. So remember this, closed circles equals a less than or equal to sign, and open circles means just a less than sign, so a sign without the line underneath. Let's now find the range of our continuous graph. The steps here are going to look really similar to finding the domain, but this time we know we want to pay attention to just the y values or just the y-axis rather than the x-axis. So this time we will look for the point farthest at the bottom, then we will look for the point all the way at the top, and finally we will create an inequality with y in the middle using the number that we found at the bottom and the number that we found at the top. So let's look at our example one more time. Step 1 says we will look at the value at the bottom of this graph. So if we find the lowest point on this graph, we notice that this is at -2 on the y-axis. And again, we're just worried about the y-axis here. We're not worried about the x-axis because we are finding the range. Next, we will look at the point that is at the top of this graph, so the highest point on this graph. And we notice that the highest point on this graph is located at 5 on the y-axis. Finally, we will take -2 and 5, and we will write an inequality with y in the middle. But again, we notice that we have 2 closed circles at either end of our inequality, so we need to draw the line underneath our inequality statement. So our final inequality statement for our range says -2 is less than or equal to y, which is less than or equal to 5. Pause the video for a moment and try to find the domain and the range for this example. Hopefully you found that the domain is -5 is less than or equal to x, which is less than or equal to 4. And that the range is -2 is less than or equal to y, which is less than or equal to 0. If you're not sure how I did that, go back and watch the previous steps. But what happens when we have a graph that looks like this? This graph looks different than the 2 graphs that we looked at before because I noticed that my endpoints at the top of my graph are 2 arrows. And so something special is going to happen when we have this type of situation. In order to find the domain and range of this situation, we will follow the same steps as we did before, except we have an important note that we need to add here, which says that if the value furthest to the left or furthest to the right of my graph is an arrow, I will use an infinity sign instead of a number. So when I look at this graph, I notice that the point all the way to the left is an arrow. And I also notice that the point all the way to the right is another arrow. So I have an infinity sign on both sides of my graph. I also notice that because those arrows will go on forever, I have a line underneath my inequality symbol. But if we end up with an arrow on both sides of our inequality, then rather than saying that we have infinity on both sides, we will instead say that our domain is all real numbers. So our domain is all real numbers. And this would be true if this happened for our range as well. If we ended up with infinity signs on both sides of our range, we would also say that the range is all real numbers. But in the example that we have here, we will notice that actually we don't have an arrow on both sides of our range. We need to follow the same steps that we have here, and we will only have one arrow this time. So we will look at the points at the bottom and at the top. We'll create our inequality symbol, and if there's an arrow, we will use an infinity sign. And I do see an arrow on one side on the top of this graph, but I notice that there is a point at the bottom, and this point at the bottom is -2. That is the least or the lowest point on this graph. So I would say that my range is -2 is less than or equal to y, which is less than or equal to infinity. But if I end up with an infinity sign on just one end of an inequality, I can take away the side that has the infinity sign, and I can just use the half of the inequality that does not have the infinity sign. So let's see what this looks like. I can take away the side that has the infinity symbol on it. And then finally, I really would rather that y be on the left side of my inequality, because I generally like to have my variable written first if I only have a one-sided inequality. So I'm going to flip this around. But I need to make sure that my inequality symbol is still facing the correct direction. So I want the open side of my inequality to be facing towards y, and I want the small side of my inequality to be facing towards -2. So my range now reads y is greater than or equal to -2. Go ahead and pause the video for a moment and try this domain and range. Okay, hopefully you got that our domain is x is greater than or equal to 1. And the reason that this is x is greater than or equal to 1 is because we have an arrow on one side of our inequality for our domain. We have an arrow all the way to the right of our graph. And when we have an inequality or an arrow on one side of our inequality, we will use just the other half of our inequality, and we will generally write our variable on the left-hand side. If you ended up with 1 is less than or equal to x, that is also correct. However, we like to write our inequality we like to write our variable on the left. We should have also ended up with our range is less than or equal to 4. And the reason why we end up with that is because we have an arrow on one side of our range. We have an arrow on the lower side of our range. So we have 4 at the top, and we notice that the arrow was pointing down, which means that all numbers that are less than 4 on the y-axis get to be included in our range. All right, everyone, if you still have questions, go ahead and watch this video one more time. And if you're really stuck, shoot Miss Mac an email. Thanks so much for watching, and don't forget to like and subscribe.